Once again back to my YouTube channel Sriram Devarajan. Today I am going to discuss another problem from CSIR NET Mathematical Science question paper. This problem was asked in December 2023. The problem is question number 2, question ID 704101. This problem is based on Volterra integral equation. This problem is given as y of x equal to e power x plus integral 0 to x 1 plus x square by 1 plus t square y of t dt, and I have to choose which of the following statement are true. Since the problem was asked in part C, more than one option is the correct option. Option 1, y of 1 which is equivalent to 1 plus pi by 4 of e. Option 2, y of 1 1 plus pi by 2 of e. Option 3, y of root 3 1 plus 3 pi by 4 e power root 3. Option 4, y of root 3 equal to 1 plus 4 pi by 3 e power root 3. Since the problem is Volterra integral equation, I am going to take the given equation as 1, comparing 1 with standard Volterra integral equation y of x which is equivalent to f of x plus lambda integral 0 to x k x comma t y of t dt. Here f of x equivalent to e power x, lambda is 1, k x comma t which is equivalent to 1 plus x square by 1 plus t square. Let km x comma t be the mth iterated kernel, then k1 x comma t which is equal to, I am going to solve this Volterra integral equation with the help of resolvent kernel. That's why I am using km x comma t be the iterated kernel. I am finding out k1 x comma t which is nothing but k of x comma t. K of x comma t is nothing but 1 plus x square by 1 plus t square. In general, km x comma t which is equivalent to integral t to x k x comma z into k m minus 1 z comma t dz. With the help of km x comma t, I am going to find k2 x comma t. What is k2 x comma t? integral t to x k x comma z, put m equal to 2, it becomes k z k1 z comma t dz, which is equivalent to integral t to x. Already k x comma t is 1 plus x square by 1 plus t square. K x comma z becomes, in place of t put z, 1 plus x square by 1 plus z square. K1 z comma t is equivalent to k x comma t. Replace x by z. Into dz. Both these terms will get cancelled. I am taking 1 plus x square by 1 plus t square outside. Integral t to x dz. Integration of dz is z, upper limit is x, lower limit is t. Answer is 1 plus x square by 1 plus t square z, limit t to x, substitute the limit 1 plus x square by 1 plus t square x minus t. This is k2 x comma t. Now I am going to find k3 x comma t, integral t to x k of x comma z, k2 z comma t dz, which is equivalent to integral t to x k of x comma z. K of x comma z means 1 plus x square by 1 plus z square into 1 plus z square by 1 plus t square. K2 x comma t, k2 z comma t is 1 plus z square by 1 plus t square z minus t into dz. Again these two will get cancelled. Remaining term 1 plus x square by 1 plus t square integral t to x z minus t dz. Integration of z minus t dz is 1 plus x square by 1 plus t square. Integration of z minus t dz is z minus t whole square by 2 with limit t to x, which is equivalent to 1 plus x square by 1 plus t square into 1 by 2 x minus t the whole square. Upper limit I am putting in place of z x, lower limit is already t minus t, it becomes 0. It can be further written as 1 plus x square by 1 plus t square x minus t the whole square by 2 can be written as 2 factorial. We have found out k1 x comma t and k2 x comma t, now k3 x comma t. Proceeding like this, we get k4x comma t as 1 plus x square by 1 plus t square x minus t the whole cube by 3 factorial. Since I am going to use resolvent kernel, we know very well R x comma t comma lambda, this is resolvent kernel. This R x comma t comma lambda can be written as summation m equal to 1 to infinity lambda power m minus 1 km x comma t. Here lambda is 1, therefore summation m equal to 1 to infinity lambda is 1 it can be further written as km x comma t. I am going to give values for m. If m equal to 1, it becomes k1 x comma t plus k2 x comma t plus dot dot dot. Already we found out the values for k1, k2. Substitute all these values here. We get resolvent kernel R of x comma t comma lambda. Therefore, already we found out k1 x comma t. It is 1 plus x square by 1 plus t square. k2 x comma t 1 plus x square by 1 plus t square x minus t by 1 factorial. k1 k2 now k3 1 plus x square by 1 plus t square x minus t the whole square by 2 factorial plus dot dot dot. Take 1 plus x square by 1 plus t square outside. 1 plus x minus t by 1 factorial plus x minus t the whole square by 2 factorial plus dot dot dot. This is equivalent to 1 plus x square by 1 plus t square. 1 plus x minus t by 1 factorial plus x minus t the whole square by 2 factorial. It is in the form of exponential series e power x. Here x is x minus t. Therefore, resolvent kernel is e power x minus t 1 plus x square by 1 plus t square. Therefore, the required solution of the given problem 1 is y of x f of x plus lambda integral 0 to x or x comma t comma lambda f of t dt Here f of x is e power x, lambda is 1, integral 0 to x, or x comma t comma lambda. Just now we found out 1 plus x square by 1 plus t square e power x minus t f of x is e power x, f of t is e power t dt, which is equivalent to e power x one plus x square e power x integral 0 to x e power minus t e power t by 1 plus t square dt, which is equivalent to e power x plus 1 plus x square e power x, e power minus t, e power t both will get cancelled. Integration 0 to x dt by 1 plus t square, it is nothing but tan inverse of t which is equivalent to e power x plus 1 plus x square e power x. Because of limit is 0 to x, it is nothing but tan inverse of x minus 0. E power x 1 plus x square e power x into tan inverse of x. This is y of x. I am going to check the answer for y of 1 and y of root 3. I am going to give the value for x, that is 1 for the first option. Whether first option is the correct one or second option is the correct one. Since I am putting x equal to 1, e plus 2e tan inverse of x, tan inverse of 1, tan inverse of 1 is pi by 4. This is e plus pi e by 2. Take e outside, 1 plus pi by 2. For y of 1, second option is the correct one. Now I am going to give the value for x by checking the option whether third option is the correct one or fourth one is the correct one. I am going to give for x equal to root 3. Y of root 3, which is equivalent to e power root 3 plus 1 plus root 3 the square into e power root 3 tan inverse of root 3. Which is equivalent to e power root 3 plus 1 plus root 3 square, 1 plus 3 square, 1 plus 3 square, 1 plus root 3 square means 1 plus 3. It is 4 e power root 3. Tan inverse of root 3 is tan inverse of root 3 is tan 60 is root 3, therefore it becomes pi by 3. I am taking e power root 3 outside. Answer is 1 plus 4 pi by 3. Fourth option is the correct option for this problem. Since it is from part C, option 2 is the correct one and option 4 is the correct one for this Volterra integral equation problem. I will upload more videos from CSIR NET Mathematics Science Question Paper as well as GATE Mathematics. Subscribe my channel, like my channel, share my channel to your friend. Thank you.